to here? Little h. What's the distance from here to here? Big H, right? Capital H. Okay. Yeah? Do you see?
Right. It's not as natural as I thought. Is H equal to 2 times H?
No, we don't have that. That's not given as a condition.
Is it similar triangle?
Similar triangles. Do y'all see them? There's one here and one here. That one and that one are similar triangles. Do y'all see them? Pardon me? This triangle, we'll call it A and triangle B, right? Do y'all see that they both have the same angles so that they're similar? Right? This angle is the same as this angle. And they both have 90s, which means this angle and this angle are the same. Let me draw those two triangles, A and B. They're not the same size, they're similar, right? Yeah. Tell me what this side is.
A is H, big H minus little h.
Big H minus little h.
And then triangle B is just little h.
And this is little h. Do y'all see that? The distance from here to here is that full distance, take away that distance. And then this side is just h. Good. And this side is what? Big R minus little r. And this side is just little r. No? Oh, wait, hold on. Hold on. No. I switched them. That's backwards. Sorry. Yeah. From here to here is r, right? Little r. And then from here to here is big R minus little r. There we go. That's it. We need an equation that relates little r and little h together. I can set up a ratio, right? Any way I want. Let me do this over this equals this over this. I'm just going to write it down. Big H minus little h over little r equals little h over big R minus little r. Now you told me you didn't want numbers, right? You wanted to leave them as constants. But just so you can see it, just imagine that this was the number 10 and that this was the number 6. Okay? What would that look like? We would have 10 minus h over little r equals h over 6 minus r. And do you see that this is an equation that has little r and little h in it? You should be able to solve this for little r or little h, because these are constants. So that's what I'm going to do. I don't know where. I'm going to just squeeze it in over here. What do I want to solve for? What do y'all want to solve? I don't even know what I want to solve for. I'm going to just do this. I'm going to multiply, clear fractions out by kind of cross multiplying. Okay, so I multiplied here to here and here to here. That's true, right? I'm going to distribute this all out. So big R, big H, minus little h, big R, minus little r, big H, plus RH equals RH. Oh, wow.
Can you divide by h?
Don't these cancel on both sides?
Yeah.
Don't they? Right? I can subtract RH from both sides. 0 equals capital RH minus little h capital R minus little r capital H. Solve for what? I don't care. Little h or little r? I think I'd rather solve for h. So I can replace this h. Right? So let's move this to the other side. Capital R capital H minus little r capital H equals little h capital R. Divide both sides by capital R. These cancel, so we get capital H minus H over R, little r, equals H. Now I did this for a reason. I'll explain it here. This is just H, right? Capital H and capital R are some numbers we don't know. So I put them as a fraction sitting in front of the variable R, because it's just a constant sitting in front of R. And then I have on the other side H. That's it. We have it. We've solved for one of the variables. So I can come back now and write my volume as a function of just R. It's going to be pi times little r squared times H, which we just found to be capital H minus capital H over R, capital R, times little r. That is my volume formula. I'm not ready to differentiate. I'm not ready for a domain yet. I'm going to clean up, distribute, boom, boom. When I multiply these two together, the pi is a constant, the capital H is a constant, the r squared is there, minus when I multiply here to here, the pi is a constant, the capital H is a constant, capital R is a constant, little r cubed. Right, all that happens is this gets another r on it, and then the H over R and the pi. This is my objective function of a single variable. And now domain. So now we can talk about R. What's the restriction on R? Little r. Careful.
0.
Remember the picture? It was cylinder inside of the cone, right? So
Be less than big R, less than big H.
it has to be, the radius has to be, the smallest it could be was 0, and the biggest it could be would be capital R. Right? Because this cylinder's radius can go all the way to 0, which would just make it like a line going straight up, and then all the way out, which would make it a flat disk. It's closed interval, though. Yeah, this is grinding, huh? Well, we can't do Desmos,
Is 0 closed?
right? Because these are arbitrary numbers.
Is 0 closed interval?
The radius can be 0, so yes, it's closed. All right, I need to differentiate because I'm almost out of time. V prime of R. Okay, look at this. Pi and capital H are constants. They come for the ride. 2 comes out. 2 pi capital H R. Okay, minus. Pi is a constant. Capital H is a constant. Capital R is a constant. They all just come for the ride. 3 comes out, right? So 3 pi capital H over capital R times little r squared. There it is. There's your derivative. What do we have to do with that derivative? Set it equal to 0, right?
0 times just
Okay, so if I set that equal to 0, it actually looks a lot worse than it is. If I had to set that equal to 0, do you see they both have r's in them? I can factor an r out. 2 pi capital H minus 3 pi capital H over R, capital R, R, equal to 0. So I pulled just an r out. Right? Now, if I set r equal to 0, I get 0. But isn't 0 one of my endpoints?
Yeah.
So I don't need to consider that. So really what I need to do is set this equal to 0. 2 pi capital H minus 3 pi capital H over capital R times R equals 0. I'm so close. Move this to the other side, right, which makes it a positive on the other side. like that. That's me cheating. And then let's just start clearing things out. Divide both sides by h. Divide both sides by pi. Multiply both sides by capital R and divide both sides by 3. Oh my goodness. That's it. That's my critical number. Isn't that just saying 2/3 of the big radius is a critical number?
Yes.
Now I'd have to check, right? I'm supposed to take this, plug it into the original volume function, and the two endpoints, right? But I don't need to do this. I know what happens when I plug 0. If my radius is 0, I have no volume. If my radius is the big radius, it's flat, and I have no volume, right? I know this has got to be where I have a max. So we've answered the question. If you have a cone with the radius of capital R and a height of capital H, and you stick a right cylinder in here, in order to get the most volume, you're going to make the radius of this cone 2/3 of that radius. 2/3 of it, and that will give you the greatest volume.
Is that why they leave the middle of the ice cream cone?
I don't know. Okay, we only have 7 minutes. Should we talk about the test? Okay, sorry about this. I mean, this is just one of those things you have to see. The one that I remember is it was a cylinder into a sphere. That was the one I remember seeing as a student, being like, "Whoa, what?" Because when you do the cross section of that one, you get this picture instead. It's harder. It's not similar triangles. You got to connect this to here, and then it's weird. Okay, the test. So you're gonna have a test on Tuesday. Study your homework. Is that good?
No.
What do you want? What do you?
The exact chapters, maybe? The exact.
Yeah.
Some specific practice. To read the whole book.
Okay, here's an exam that I gave in the spring. Okay. Now, this is not following the format of this class because we're at different places and stuff, but let's just look. This is related rates, right? So on our last test, did we have related rates? We did not, right?
We stopped at chain.
Yeah, we need implicit differentiation. So related rates, look what I did here. Do one of the following. So I gave them 3 to choose from. All right?
Boom.
Then the next question is find the derivative. This is basically just product and chain rule. It's just making sure students know how to take derivatives of logs, right? Because we learned about how to differentiate logarithms. And then the second problem is how to differentiate exponentials. But this is a product rule with chain, right?
So how do you know which one to do first? Does it just depend on the question?
What do you mean to do first?
Chain or product rule, which one becomes?
Yeah, that'll depend on the question. Yeah, these are products. And while you're doing the product, there's chain, right? Because when you take derivative of the first one, it's just 3x squared times the second. Then plus, when you take derivative of this, that's chain because it's natural log of x squared plus 1. Okay, what is this one? What do you think number 3 has to do with? Find the derivative, sine x to the sine x. Bring what?
Are we going to bring sin x to the front?
You're going to try and bring sine x to the front, but how are you going to do that? You have to start, this is logarithmic differentiation. right? Logarithmic differentiation, where the key on this was when you saw a function of x raised to a function of x. You're gonna do y equals this, do log on both sides, bring it out, and then take the derivative. Do y'all remember what the derivative of the left side is going to be every single time? 1 over y prime, or 1 over y dy dx. And then the right side will always be a product rule. Do not confuse this with L'Hopital. Most students mess this up because they confuse it with L'Hopital.
Don't you do L'Hopital at the end?
Nope. You're going to have to look back in your notes. So far, what do we have? Related rates. Pick one. We have derivatives of logs and derivatives of exponentials. We have logarithmic differentiation. The next one, find limits. Infinity over infinity. L'Hopital, right? Limit x goes to 0 of square root of x times natural log of x. If you let x go to 0, you're going to get 0 times infinity. That's L'Hopital, but what do you have to do first? Make it either 0 over 0 or infinity over infinity. So you have to pick one and drop it, right? Yes?
Sir, if related rates is 2.7 and if 3.3 is the exponential log, what's the one after that before L'Hopital?
I don't know.
Is it 3.5? Derivatives of inverse straight function?
No. Mm-mm. Logarithmic differentiation takes place in 3.3.
Yeah.
So what are you asking me?
The one before L'Hopital, I think question 3.
This is 3.3 as well.
Oh, it is?
But yeah, logarithmic differentiation takes place in 3.3. Yeah, it's in 3.3. All right, here's another limit where you're going to get 1 to the infinity. 1 to the infinity. So here's where you have to bring in a log, and then it'll turn into like 0 times infinity. Then you drop 1, and then you do L'Hopital. Do not confuse a problem like this with this problem here. Here I'm asking for the derivative of something where you have x both in the base and exponent. That's one thing. That's a derivative. That's logarithmic differentiation. This problem is a limit where you have to do logarithm so that you can get it to a point you can use L'Hopital. All right, find the absolute maximum minimum value of this function. That was your quiz problem, wasn't it? That was the problem I gave you for a quiz.
So, yeah.
Yeah. Find where it's going up, where it's going down, find local max, mins, where's it concave up, where's it concave down, find inflection points. Okay, that was that particular test, but they had more tests in that class, so let me look up exam 4. There we go. Okay. First problem, implicit differentiation. This will be on your test. This will probably be the first problem that you have on your test, because this comes right after chain rule. Right? Implicit differentiation, that's where you have to take the derivative on both sides of the equation with respect to x, right? And here I'm asking for the equation of tangent line, so you have to figure out what dy dx is. In this particular test, I didn't give them an option. I all forced them to do a plane flying overhead. And I think that's because I did that problem in class. So look at this, number 3. Y to the sine x. Doesn't that look like the sine x to the sine x we just saw? Again, logarithmic differentiation. You have x's in the base and the exponent. If you got to go, you got to go. I'm just going to keep going here. I'm not in a super big hurry. The next one, Ooh. What the hell? Derivative of this? Who wants to do the derivative? Who wants to do quotient rule on that? Nobody, right? That's because this is also logarithmic differentiation. Do you remember that problem we did where I took log on both sides and then used all the properties of logs to like rewrite everything and then took the derivative? That's what this problem is.
So you would
Take natural log on both sides and then split that, make it subtraction, and then anywhere you have products, make it addition, and then any powers come out. And once you get it to that, then you take a derivative.
So
Yes?
If we were to do that problem using quotient rule instead, just quotient product and whatever,
Yeah.
would you give us a bonus?
If you bonus, no.
You get it right.
If you get it right, I'll be happy for you, but I won't give you bonus. Only because I feel like you're working harder than you have to actually. You know. Number 5. Limit as x goes to 0. So here you get, that's the same problem, wasn't it? That was the same problem I gave on that other one. Same with this one. This is 0 to the 0. Instead of 1 to the infinity, this is 0 to the 0. So more L'Hopital. Do y'all see there's a switch here? Here I'm asking for the derivative. Here I'm asking for limits. That's where we're switching from logarithmic differentiation to L'Hopital. Critical numbers. Find the critical numbers of this. Find the absolute maximum minimum values of this function on a closed interval. Closed interval method. Find the values of C on the interval 1, 3 which satisfy the mean value theorem. We remember us talking about the mean value theorem? We did. And then I gave him a function. Where's it increasing, decreasing, local max, mins? I kept the function pretty nice here, right? It's polynomial. Inflection points. Okay, we haven't done that stuff yet.
Are both of those exams, are they in the, no?
They're not on our file?
I just gave these last semester. Let's see if I got something older. See what this looks like. Oh, that's the same one. Final exam? Yeah, if you want to go. Let me see here. Chain. Okay, here's another exam. Just kind of showing you this to show you. This is another exam where you have some implicit differentiation problems. Oh, wow. Yeah, that's not really applicable. Here we got related rate problems. Oh my gosh, I was brutal this semester. So the way I see the test